Hi, my name is Deepak Kumar Tyagi and my student ID is 2317801 and today I am here to present my research project. So the title of my research project is Cloud-Centric Hybrid Encryption Framework using Attribute-Based Encryption and Lightweight Cryptographic Algorithm. Coming to the research question, so basically, we can break down our research question into two different questions. The first one is how can we design a secure hybrid system for cloud environment that uses ABE and the combination of lightweight cryptographies? And the second question is why this hybrid method is better than the traditional encryption method. So this is basically my research question. Coming to the introduction, we have the problems. So the problems with the traditional encryption method like RSA or AES is that they only encrypts the data for specific users or keys. So uh, coming to the security gaps, there are a lot of security gaps in the traditional method. Like first one is static control. You can assign permission to the fixed user only. If someone changes their role or team, you need to redo everything manually. Second one is multi-tenancy risk. In cloud systems, multiple users share the same physical servers. This increases the chance of data leak or the unauthorized access. Third one is resource constraint in IoT. Devices like sensors, wearables, smart watch, and the smart home tags cannot handle a big encryption system like RSA. They need fast and simple algorithms like SPEC. Coming to the solution, so our proposed solution for this problem is a hybrid framework which combines attributes-based encryption with SPEC, ECC, ChaCha, etc. Coming to the why this work, ABE. ABE ensures only the right users based on attribute like role or department can decrypt, while ECC handles secure key sharing with less power, and Chacha is great for cloud system which needs fast performance. Coming to the performance, if we talk about the performance of the lightweight cryptographies, the combination of ECC and Chacha gives a good encryption speed with 2.5% of the CPU usage only, which is very efficient. Now coming to the research aim and objective. So our primary aim of this research is to create a better encryption system for cloud storage, which is both secure and fast and the energy efficient as well. So the objectives of our research is to combine uh, lightweight cryptographic algorithms and attribute-based encryption, which will result in the better performance as spec takes only 30 milliseconds for the encryption and 187 milliseconds for the decryption. Also, we get the maximum throughput as well. So all this will result in the resource efficient environment as there will be less CPU memory usage. So moving forward to the security validation, Chacha also has the best avalanche score. So coming to the avalanche score, I will show you my scores later on. Moving forward, methodology, key and key concept. So ABE ciphertext policy is an advanced encryption scheme where access policies are directly integrated into ciphertext. Only users whose attributes satisfy the policy can decrypt the data. For example, Here, the ciphertext is encrypted in such a way that only users with role, admin, and department IT can decrypt it. Coming to the elliptic curve cryptography, it is an asymmetric encryption method that uses elliptic curve mathematics to secure key exchanges. Its key size is 256 bit, which is equivalent to RSA 3072-bit security. Its role in the framework is securely key exchange and to provide stronger security with smaller spec. Spec is a symmetric encryption algorithm developed by NSA. It is used for low power devices as it is a lightweight block cipher. Its encryption time is very fast, which is 30.5 milliseconds. Chacha. Chacha is a high-speed symmetric cipher designed for software efficiency. It has a 256-bit key. It has a slower encryption time than the spec, but still faster. It is still faster, which is approximately 56,592 milliseconds. And the throughput is also ideal for the large data. Moving forward to the workflow, in this framework, encryption and decryption follows a three-step approach. First one is, so the step one is before encryption or decryption, the system checks if the user's attribute match the access policy. Step two is a 128-bit symmetric key is generated. Step 3 is a symmetric key is used to encrypt the actual data. Coming to the system architecture. So in system architecture, we have a user layer. It captures the user attributes, for example, role, department, to determine access rights, etc. Users submit their credential that map their attributes. While ECC generates a 128-bit symmetric key and encrypts this key using a ECC 256 and transit the encrypted key alongside the ciphertext. While SPEC is used for low-power devices like IoT sensors, Chacha is preferred for cloud work like which has the more for data load like video streaming, etc. Data is unreadable without symmetric key. Even with the key, decryption requires ABE policies. The system then verifies the user's ABE private key, satisfy the ciphertext. The authorized user decrypt the ECC encrypt key using their ECC private key. Then system track the metrics like throughput, CPU, memory usage in real time. Now let us take a look at my coding part. Here is the coding part. So this is the Chacha algorithm. So here we have like we begin with the importing some necessary libraries. Here this function measures the system resources usage like CPU usage, etc. Coming to this function perform using Chacha 20 stream cipher. Decryption is simple. Here we recreate the cipher with the same key and nonce and decrypt the ciphertext to get back the original data. Mm, Here we measure how long it takes to generate the key using the part counter for high resolution timing. Here we uh, encrypt the plain text and record how long it takes. So here in the main block, we pass a simple plain text to the function. So here we have passed a plain text called as secure chacha20 message example. So like we can change this and we can do anything. Suppose we wanna pass a, we can change this. Suppose we wanna pass this line and we want to run this code. So here we get all the results. Here is the ciphertext for our plain text, and here is the decrypted data. It is the total encryption time, and this is the total decryption time, total throughput, total CPU usage, total memory usage. Likewise, we have calculated everything in this. Coming to the Cha-Cha and ECC. So here are the basic libraries we have imported. Uh, so coming down to this. Here the function generates the ECC private key using the random numbers. Coming down, here it measures the CPU usage and memory usage. In the main domain, we have passed the plain text like hello, this is a secure message using ECC and Chacha. So after running this, we have got the ciphertext for this plain text and the total encryption time, total decryption time, total throughput, total CPU usage, total memory usage. Everything we have got in this. Same is with the spec and ECC combination. We have imported the required libraries here. We have generated the key pair using the we have generated the key pair here, and same is this here. Coming to the spec, in spec also we have passed this plain text spec encryption now. So when we run this, we will get all the values here like escape spec encryption now. So the for this plain text ciphertext is this, and the decrypted data is this, total encryption time is this, total decryption time is this, and we have made a table for all these results, and we have compared uh, different results. We'll show you that table later. Moving back to the PPT. So here is the system architecture diagram. Here this the attribute-based encryption, elliptic curve cryptographic, symmetric encryption. We have used all these algorithms. Coming to the results of the table which I was talking. So here we can see this is the first algo we have used spec and ECC. So the result for this is like we have used a 1 bit data, and the data we have used is here. So we have got the throughput here, and we have changed this data. And after changing this data, first the data was original data was good morning sir, and now in the change data we have changed the spelling of sir. And then we can clearly see that the decryption time and the encryption time has changed, the throughput has also been changed, and we have also calculated the avalanche score at the end. So the avalanche score for spec and ECC for the first data is this 84,000 8 lakh, something like this. Coming to the Chacha and ECC, same with them as well. And spec, same is with them as well. Like we have taken first original data, and we have taken out their decryption type, encryption time, and throughput, and then we have changed that data. Then we have again taken out their decryption type and encryption time, and then we have taken out their avalanche score. Same is here with Chacha as well. Let me show you now the front end of my project. So this is the home page, and after the home page we can scroll down and we can start encryption. So first algo is the combination of spec and ECC. If we enter a plain text here, it will give us the results like CPU usage, throughput, and everything. So let us type a plain text here, hello world. So when we type this plain text here, hello world, it gave us all the details here. See, the input data was hello world, ciphertext is this, decrypted data is again the hello world, total encryption time taken is this, total decryption time taken is this, total throughput is this, total CPU usage is 0, as it is very fast and it takes very low CPU usage, and the total memory usage is this. Coming to the Cha-Cha plus ECC algo, same as with this. If we wanna give it a plain text like Deepak and encrypt, it came with the results again. So like we have taken the results for each of the algos. Like first we have taken the results for the combination for spec and ECCs. Then we have taken the result for the combination of Chacha and ECC. Then we have taken the results of the individual spec, like this one. And then we have also taken the results for the individual Chacha. All these results are shown here. We have combined all these results into a one simple result so that we can compare all of these in a simple, let me show you. So here we can see the different results here. So for the spec and ECC, the avalanche score for this is spec and ECC is very low here compared to the Chacha. Coming to so the gray one is the Cha-Cha and ECC. It's a bit good than the spec and ECC. Spec alone, it's poor, and the Cha-Cha is the best one. So here are the avalanche score. Coming to the case studies and results. Mm, This paper compares 4 different key cryptographic configuration tested under different workload scenarios to see which work best in the real world cloud system. Each method was tested for the encryption, decryption time, throughput, CPU, memory usage, and security avalanche effect. So the results for first spec and ECC. It was a balanced performance, low throughput, not ideal for the large data, but sufficient for the small IoT sensors. CPU efficiency is below 5%, which makes it suitable for the battery operated devices. Coming to the Chacha and ECC, highest throughput, which means it is good for the bulk data processing, moderate latency, slower than the spec. CPU usage, despite the high throughput, it has very low CPU usage of 2.5%. Coming to the alone spec alone, it has a very low latency, which means best for the real-time applications, and it has zero CPU load. Coming to the Chacha, it has the highest avalanche score, which means it provides the highest security and consistent performance. So after seeing all this, we can conclude ECC and SPEC are ideal for IoT sensors, and Chacha and ECC could be used for larger data. So now coming to the conclusion and the future work. So here the conclusion draws and the proposed future enhancements for the hybrid encryption framework is that the proposed system addresses three critical challenges in the cloud security. First one is fine-grained access control. The solution for this is use CP/ABE interface attribute-based policies. Second challenge is scalability. So the solution to the scalability is that lightweight algorithms reduces the computational overhead. Third challenge is the performance. Is so the solution for this is spec optimized for the IoT devices and Chacha for cloud big data like the online streamings and the videos, and for the big data Chacha could be used. Limitations of my work is like currently the implementation uses simplified logic, full library integration. Chacha's speed drops according to hardware. So coming to the future work problem, ECC and ABE are vulnerable to quantum attack. So the solution for this is to migrate to lattice-based ABE and post-quantum ECC alternatives. Second one is current ABE policies are static. So as a solution, we need to implement revocable ABE. Sometimes performance varies across different cloud providers. So as a solution, make an encryption system that work equally well across different cloud providers. So these are all the conclusions and the future work, and this is somehow my project was. And thank you very much.